Hello everyone, I am Hitesh Gupta and I will be presenting my work on the assessment of GHRSST on the detection of marine heat waves and marine heat spikes in the Bay of Bengal. So first I'll introduce about the importance of studying and assessing the satellite SSTs. So most of the heat transfer occurring at the air-sea interface are nothing but the manifestation of the sea surface variability. So there are some of the phenomena that can be studied by the satellite SST, which includes the monsoon prediction, tropical cyclone monitoring, fisheries management, climate change and the marine heat waves. Now, as a result of the global warming, marine heat waves or marine heat spikes are becoming more frequent and has a very critical impact on above stated systems. These also affect the chlorophyll of a region. Therefore, accurate SST measurements are extremely crucial to firstly detect and then understand the impact of these so-called marine heat waves and marine heat spikes. So these are the objectives of the study. So first, we will assess the satellite derived SST, that is OSST and GHRSST, in the open ocean or the deep water region as well as the coastal or shallow water region of the Bay of Bengal against in situ observations. Then we will assess the OSST and GHRSST against the in situ observations in identifying marine heat waves and marine heat spikes in the Bay of Bengal. So these are the data sets used for the study. Now we have compared GHRSST and OSST with various in situ instruments available in the Bay of Bengal region as shown in the figure, and which includes Rama buoy at 15 north 90 east and some of the omni buoys like BD10 and BD11 and 3 wave rider buoys present near the Pondicherry, Vizag and Digha, that is near the coastal region of the Bay of Bengal. Now to utilize and compare GHRSST and OSST with in situ measurements, we have taken an average of 4 nearest neighbors. Moreover, we have filled the gap in time series due to the data unavailability. For 1 to 2 day gap, linear interpolation is utilized, which are generally used. And for long stretches of missing data, which was unavailable only at Rama mooring during the near end of 2019, we have utilized repetitive moving mean method to avoid long stretches of increasing or decreasing values. Also, we have removed the outliers present in the wave rider buoy using the median based outlier detection method. Moreover, wavelet analysis of GHRSST OSST against RM15 has also been carried out to understand the SST variability in all these datasets. And lastly, marine heat waves and marine heat spikes have been detected. Marine heat spikes are defined as the temperature above 98th percentile threshold, whereas MHWs are marine heat spikes but persist for at least 5 days. Daily intensity is temperature anomaly above climatology when MHW and MHS criteria has been fulfilled. Now we will proceed to the results of the study. So here we have compared the GHRSST and OSST with the Rama buoy present at 15 north, that is we are calling it with RM15, and we have observed excellent performance of OSST and GHRSST against Rama buoy, as RMSEs are very low and correlations are very high. Also, the trends captured by all these datasets are more or less similar in all the three cases. Then we have compared GHRSST and OSST with omnibuoys, that is BD10 and BD11 present in the Bay of Bengal region, and we found good performance of GHRSST and OSST against both the BD10 and BD11 as RMSEs are low and correlations are high. Little underestimations of GHRSST and OSST with respect to omnibuoys are observed, which are more or less negligible. Hence, we can say that GHRSST and OSST performs well in open ocean region uh, in the Bay of Bengal in the terms of daily SST comparisons. Then we compared the GHRSST and OSST with the wave rider buoys present near to the coastal region of the Bay of Bengal at Digha, Pondicherry and Vizag, and we observed reduced correlations, frequent underestimations or overestimations, comparatively high RMSEs of GHRSST and OSST with respect to wave rider buoy in the coastal region of the Bay of Bengal, and hence GHRSST and OSST might not be suitable or reliable to study SST related processes like upwelling or downwelling in the coastal regions of the Bay of Bengal, and hence it should be used with caution in mind while studying the coast related processes. Later on, we have carried out wavelet analysis of RM15 first row, GHRSST second row, and OSST third row. So wavelet analysis is used to understand the dominant modes of variability. These so-called dominant modes are nothing but the processes occurring at a certain frequency, driving the SST and leading to its variability. So using wavelet analysis, we can identify whether these processes or variability captured by the Raman buoy occurring at a certain time period over the years are captured by satellite SSTs or not. So here in the first column we have a whole signal of SST from Raman buoy, and we can see that the semi-annual signals and the annual signals are captured by both GHRSST and OSST when compared to Raman buoy. To observe high frequency or low time period signal clearly, we have filtered out sea surface temperature for 2 to 4 months signal, that is second column, then 1 to 2 months signal, that is third column, and some monthly signals for the in the fourth column. So we have made blocks as mentioned on the right hand side, where time corresponding to black box has not been compared due to unavailability of Raman buoy data, which has been filled using repetitive moving bean method. And then translucent blue block represents the time in GHRSST and OSST when pattern and power matched with that of the Raman buoy. Similarly, transparent blue block represents the time when only the pattern has been captured but not the power, and red block represents the disparities in satellite data with respect to the Raman buoy. So it can be seen that 2 to 4 month signal are almost perfectly captured by both GHRSST and OSST, but the performance of both GHRSST and OSST degrades in capturing the signals occurring at 1 to 2 month or some monthly periods. Overall, GHRSST has performed better than OSST in all the cases. Then we compared the climatologies and standard deviation along with seasonally varying 90th percentile values obtained from GHRSST, OSST, and Raman buoy. So we have represented Raman buoy with black color, GHRSST with blue color, and OSST with red color. Daily climatology shows that Raman buoy to be greater than GHRSST and OSST for almost all the time. OSST and GHRSST are almost overlapping except for monsoon season, where OSST is higher than GHRSST. Similarly is the case for 90th percentile threshold, where Raman buoy remains highest except for few periods where OSST either overlaps or dominated RM15 threshold. This overestimation corresponds to the period of high standard deviation in OSST datasets, which are utilized to calculate thresholds. GHRSST consistently underestimates both climatology and threshold when compared to RM15. This analysis of climatology and standard deviation is important as these are used for threshold calculation, which are utilized in detecting marine heat waves. Lastly, we have compared and contrasted marine heat waves and marine heat spikes obtained from Raman buoy, GHRSST, and OSST. So we can see that overestimation of both number of marine heat wave count and marine heat wave days has been observed in GHRSST and OSST when compared to RM15 as seen from the bar diagram. Then intensity of marine heat wave, or basically the daily intensity, is more or less same in all the three cases. Now MHWs plus MHSs, that is marine heat spikes, when clubbed with marine heat waves, are plotted to understand the source of inconsistency in marine heat wave count and marine heat wave days as showed by the bar graphs. So MHWs clubbed with MHS shows similar number of days and count by all these data sets, suggesting RM15 captures equal amount of MHSs as that of GHRSST and OSST. But these MHSs or marine heat spikes do not persist longer than 5 days in case of RM15 to be categorized as marine heat waves, and hence GHRSST and OSST are capturing marine heat spikes very well when compared to Raman buoy, but due to high temperature persistence as observed in GHRSST and OSST leads to more marine heat waves as compared to RM15. These are some of the references that I have utilized in this study. So thank you. You can contact me through the email as given here at g13@iitbbs.ac.in. You can visit my websites as mentioned here. So thank you.